Hello everyone, welcome to My Math Teacher. This video is the third part of the trigonometry introduction video. The first part we learned about the terms used in trigonometry. The second part was about ratios, and today in this video you will be learning about the identities. Before showing the proof of the trigonometric identities, let us try to recall the mnemonics which we studied in the previous video. That is so, ka, tova. That is so. Sin theta is opposite side by hypotenuse. Next, ka, cos is adjacent side by hypotenuse. Next, tan is opposite side by adjacent side, that is tova. Now from this we can write the inverse. So what is the inverse of sine? So inverse of sine is cosecant. Cosecant is, what is the inverse? Reverse will be hypotenuse by opposite side. Next, the inverse of cos, that is secant. Secant is, instead of adjacent by hypotenuse, it will be hypotenuse by adjacent. Next, inverse of tan is cot. That is, instead of opposite side, the reverse, adjacent by opposite side. Okay. So with this, we'll learn the first identity, that is sin theta by cos theta is equal to tan theta. How? Let us see. Now let us see sin theta. So shall we apply? What is sin theta? Opposite side by hypotenuse divided by, what is cos theta? Adjacent side by hypotenuse. That is equal to, when you divide, you will definitely get tan theta. So when you divide, hypotenuse will get cancelled. Now what is the remaining? Opposite side by adjacent. Is it equal to, what is opposite side by adjacent? Is that equal to tan theta? Yes. So we can come to the conclusion that sin theta by cos theta is always tan theta. This is the first one. Okay. The next one, the inverse. Cos theta by sin theta is cot theta. What is cos? Cos is adjacent side by hypotenuse. Is it right? Divided by sin. What is sin? Opposite side by hypotenuse. Will it be equal to cot theta? Let us check. Okay. Now we'll have only adjacent side by opposite side. What is adjacent side by opposite side? Is it cot theta? Yes, cot theta is equal to cot theta. So we have come to the conclusion that the second one, that is cos theta by sin theta, is equal to cot theta. This is the second important identity. Okay. We are going to see three basic important identities. From that we will be deriving some more identities. So let us start. Here I will be giving the proof of the identities. Understand the proof, because simply memorizing the identities will definitely not help at all. It will lead to more confusion. So observe the proof here, learn the proof. It will definitely help you to learn the basics and also the fundamentals very easily and thoroughly. Definitely help you to learn the basics quite easily and thoroughly. Now here the first identity, what is the proof? From this triangle we are going to prove that. In triangle ABC, I am going to apply Pythagoras theorem. By Pythagoras theorem is hypotenuse square is sum of the squares of other two sides. Okay. Now hypotenuse square is AC square, that is equal to, let us take the other two sides and square it. So AB square plus the next side, that is BC square. Now let us take this as equation number 1. Okay. The first step, dividing. I am going to divide this entire equation by AC square. Now both the left hand side and right hand side, you have to do it in both the sides. BC square divided by AC square, which is equal to AC square by AC square. As you can see, this divided by this will become 1. Okay. Now here, instead of writing like this, we can write AB by AC the whole square. Am I right? The square is common now. Plus BC by AC the whole square, which is BC square by AC square, that is equal to 1. Now what is AB? AB is, as we can see, this is opposite. So opposite by AC is hypotenuse. This is hypotenuse square, plus what is BC? It is adjacent side, by AC is again hypotenuse square is equal to 1. Now what is opposite side by hypotenuse? Opposite side by hypotenuse is sine. Adjacent by hypotenuse is cos. Now we can write this as sine theta, sine square theta. That is, we are squaring the sine value. Sine value. You should not write like sine theta square. That is wrong. Sine square theta plus cos square theta is equal to 1. This is the proof of the first identity. What is the proof? That is, sine square theta plus cos square theta is equal to 1. The next one, sine square theta plus cos square theta is equal to 1. So with this we can derive the next two identities. How? See here, sine square theta. If you want sine square theta, what is the answer? 1 minus cos square theta. Is it right? Next, cos square theta is equal to 1 minus sine square theta. Okay, this is the first set of identities. Sine square theta plus cos square theta is 1. If I want only sine square theta, that is equal to 1 minus cos square theta. If I want only cos square theta, that is 1 minus sine square theta. Now the second. Now I am going to dividing 1 by, I am going to divide by BC square. This equation by BC square. So how to divide? AB square by BC square plus BC square by BC square is equal to AC square by BC square. Okay, here as you can see, BC square and BC square, when you divide it will be 1. So instead of this we can write AB by BC the whole square, which is the square is for AB square divided by BC square plus 1 is equal to, what is AC? You can write AC by BC the whole square. Okay. Now what is AB here? AB is opposite side by BC is adjacent side. Opposite side by adjacent side square plus 1 is equal to, AC is hypotenuse by adjacent the whole square. Now opposite by adjacent. What is opposite side by adjacent? Tan. So we can write tan square theta plus 1 is equal to hypotenuse by adjacent. What is hypotenuse by adjacent? You can see this is secant. That is secant square theta. Okay, the second one, that is tan square theta plus 1 is equal to secant square theta. So we can write here tan square theta plus 1 is equal to secant square theta plus 1 is equal to secant square theta. So if I want only tan square, bring the 1 to the opposite side. Tan square theta is equal to secant square theta minus 1. Okay. From this we can derive, that is secant square theta minus tan square theta is equal to 1. These three are the next major 3 important identities. The next one, this equation we have divided by AC square, then BC square. Now we are going to divide it by AB square. So dividing 1 by AB square, that is AB square by AB square plus BC square by AB square, that is equal to AC square by AB square. Cancel, you will get 1. Okay, 1 plus, instead of this you can write BC by AB the whole square, both are same. AC by AB the whole square. 1 plus, what is BC? BC is adjacent side, and as we know BC is adjacent side and AB is opposite side. Adjacent side by opposite side, the whole square, that is equal to, what is AC? AC is hypotenuse by AB is opposite side, the whole square. Okay, now 1 plus, what is adjacent by opposite? It will be very helpful if you are writing this when you start practicing. So adjacent by opposite, what is that? Cot theta. So here it is square, so it should be written like this, cot square theta, that is equal to hypotenuse by opposite. So look at this, hypotenuse by opposite is cosecant theta. So already we can see there is a square, we can write like this, cosecant square theta. So now this is the last identity, the last set, that is 1 plus cot square theta is equal to cosecant square theta. Now if you want only cot square theta, how will you write? Cot square theta is equal to cosecant square theta minus 1. You can write 1 is equal to cosecant square theta minus cot square theta, or it can be written like this, cosecant square theta minus cot square theta is equal to 1. Okay. So these are the final set of 3 identities. These are the identities which we will be using while solving the problems. I hope you have understood the identities. I hope you must have understood the proof as well. So see you in the next video. Until then, take care. Bye. Keep practicing.